Hi everyone. Today we'll be discussing the LeetCode problem of the day, container with most water. So here we are given an integer array heights of length n. So there are n vertical lines drawn such that two endpoints of the ith line are from I, 0 to I, height of I. So suppose we have this line. So this line is drawn from 1, 0, the y-axis is 0, to the y-axis is 8. So we just have to find two lines such that it will form a container with the x-axis. And out of all the two lines, we have to find such a container which will hold the maximum amount of water. And it is also given that you should not slant the container. So that means, suppose you are picking these two lines, then we can just ignore all the other lines, and these two lines will form a container. So we have a container which is formed like this, and the amount of water this can hold will be the width is 6 minus 1, 5. So the width is 5 and the height is 8. So this container can hold total 40 liters of water. And we can also pick any other two lines to form a container. Suppose if we pick these two to form a container, now we can see that this height is 6 and this height is 7, but and the container will be formed like this. And if we try to fill the water will be filled only up to the height 6. Even though the right part is 7, because the left part is 6, the water will be filled only up to height 6. And the height will be 8 minus 2, 6 is the width, and height is 6. So total volume it can hold is 36. So let me just remove this. So similarly, if we again pick these two, and we have the container like this, but the water will be only filled up to this level. So the volume will be 7 minus 2, which is 5. 5 is the width, and height is 3. So the volume is 15. So in this problem, we just have to find two lines which will give us the maximum area. So the answer is picking the last line and the second line. So by doing this will form a container like this, and the amount of water we can fill is up to this height. So the width will be 8 minus 1, 7, and the height will be 7. So the volume is 7 into 7, 49. So this picking these two lines can hold at max 49 liters of water. So this is the output. Now let's quickly see the second input as well. Yeah, in this input we have just two lines. So 0, index 0, index 1. Index 0, the height is 1, and index 1 also, the height is 1. So the only way is to pick these two lines, and the amount of water is 1, because width is 1, height is 1, so the area is 1. So the output for this is 1. Now let's go over the approach. For any two lines, let's say line I and this is the line J, if we want to find the amount of water this can hold, this is equal to the width will be J minus I, and the height will be minimum of A of I, this height of I and height of J. So the width is this, and the height is min of h of I and h of J. So let me just write it here. If we have two lines I and J, then the amount of water it can hold is J minus I into minimum of height of I comma height of j. So what we can do is we can iterate on all possible I and j values and get the area and try to maximize it. So this will have a time complexity order of n square because we are iterating on all possible I and j. But since the value of n is 10 power 5, so n square will be 10 power 10, so this won't pass. We have to solve it, we have to somehow optimize the logic. So if we see the area formula, there are two terms. One is the width and the other is the height. So since we are trying to maximize the area, we want these two terms to be as max as possible. So let's see the first term. If for us to have the width as maximum, we can choose I and j as the extreme endpoints. We can have I here and we can have j here. So by doing this, we will get the maximum width. But by doing this, the height might be sacrificed because here we can see that the height of the right endpoint is 7, but the height of the left endpoint is 1. So minimum of 7 and 1 is 1. So if we take these two, the area we can form is this, and which is 8 minus 0, 8 into height 1. So we can only form 8 units, but we can see the maximum answer was 49. And another option is we have to maximize the height. So that means if we try to pick the two most tallest lines in this, the two most tallest are these. So we have I and we have j. So if we try to pick this, the height will be maximized for sure. So the height is 8, but the width will be sacrificed. So the width here is 6 minus 1 is 5, and 5 into 8, we only have 40. So we can see that if we try to maximize one term, the other term might be compromised, and if we try to maximize the height, the width might be compromised. So what we can do is first start at the maximum width, and then from there you try to give priority to the height. So what I mean to say is first start I here and start j here, and first find the area. So in this case the area will be 8. Now the width is given the most priority, and we got the area as 8. So now let's try to give height some priority. So we'll first see if height of I and height of j, which is the smallest. We can see that height of I is the smallest, so we will move I forward. We'll do I plus plus. So that means the width will be decreased by 1, but this will give us a better height. So the height will move here. We can also argue that we can move j to the previous element, but since we are trying to maximize the height, we'll first compare which is the smallest height, and that we will move forward in hope that we will find a better height. So in this example, we will move I forward, and let's find the area again. So the area will be 8 minus 1 is 7, width is 7, and the height will be minimum of 8 and 7, which is 7 again. So area is 49. Now we'll have the new area 49. So we'll update in our answer. Now after doing this, we'll again see for I and j, height of I and height of j. Now we see that height of j is the smallest one, so we move j to the left. So now j becomes here, and we try to find the area, and we keep repeating the process. So out of these both, j is smallest, so j will move here. Then again, but here we see that I and j both are same. So after calculating the area, we can move whatever we want. So let's move I. So I will be moved here, and we'll find the area again. Now I is the smallest, so I moves again. Then again, out of I and j, I is the smallest, so I moves, and then again I moves. So finally we arrived at this, and we find the area as such. After that, height of I is less than height of j, so we again move I forward. So as soon as I and j meet, we just stop, and whatever the answer we have, we just return it. Now let's quickly code it. So first we'll just take an answer variable to show the answer, and take 2 pointers. First will be at 0, and last will be at end. Height dot length -1. So like we discussed, we'll start at the two extremes, that is the width is maximized, and we'll try to move inwards. So we'll move as long as I is less than j. And now first step is just find the area. So area will be j minus I into math.min height of I and height of j. So once we have the area, just try to compare it with the answer. So answer equal to math.max answer comma area. Now once we have the area, we'll check if whatever is the shortest among I and j, we'll move that. So if height of I is less than height of j, that means we have to move I forward, and otherwise we can move j behind. So even in the equal to case, we can either do j minus minus, or we can either do I plus plus. And at the end, just return the answer. Okay, I took it as R, it should be J. Let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So for the time complexity, we are doing a 2 pointer. One is at left and one is at right, and at each point these both are moving closer, so at max they will run n times. And for space complexity, we are not initializing any additional space other than just the pointers and the answer, so it is order of 1. I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And also someone was interested in the extension I'm using to draw. So this is a Chrome extension. Let me open it. Yeah, so I'll just add a link for this in the description as well. And let's catch up in the next video.